Hi and welcome to Maths class. This is just a very short video to take you through a worked example from exercise 4A. This may not be the one that you're having trouble with, but we didn't go through any examples like this, so I'm just going to take you quickly through this one. It's question 14, so that's on page 161 in your books. So if you wanted to watch this, it might help you. So what we need to do is prove that this equation, because it equals 0, always has two distinct solutions. So the first thing I'm going to think about is the fact that these two distinct solutions tells me that my discriminant is going to be positive. And that's the discriminant of this side of the equation. So this is A and B and C. I'm looking for the discriminant is b squared minus 4ac. So all I'm going to do now is I'm going to substitute what I've got here. So that gives me a plus 1 squared, and then I subtract 4 times, a is just 1, times c, which is a minus 2. I'll expand it all out and see what I get. So I've got a squared plus 2a plus 1 minus, this is going to be 4a, and then minus 4 times negative 2 will give me plus 8, which is a squared minus 2a plus 9. Okay, I've had a quick look at that. I don't think I can factorize it easily, but if this has two distinct solutions, then this should always be positive. And when I say always, what I mean is regardless of the value of a. A can be any number, any real number. The question doesn't at all restrict what a can be. So that means that this expression, now if I make this into an equation, let y equal a squared minus 2a plus 9, y is always a positive number. So what I'm thinking is I need this to look like a parabola. I don't know where it is, but I need it to be always above the x-axis. Sorry, the a-axis, I should say. I'm graphing a against y. The fact that I've got a variable of a here doesn't change the fact that I can sketch what this looks like. I can find that when a is 0, I'm going to have 9 here. I don't need to know that, but it's information. But the most important thing I need to establish is that this particular graph never comes down below the a-axis and it doesn't give me a negative region for y. If I get a negative region here, then that means this discriminant is sometimes negative, and therefore it will not always have two distinct solutions. So I need to show that this expression has, if I let it equal to 0, I need to show that that expression has no solutions. Not one solution, because if it has one solution, then it will touch the a-axis and there will be a value for a, which gives me the discriminant equals 0. I need it to be always greater than 0. So what I'm going to do there is use the discriminant once again. The discriminant of this is equal to b squared minus 4ac, which is negative 4 squared minus 4 times 1 times 9, which is 16 minus 36, which gives me negative 20. I made a mistake here. I just realized that should be a 2. That's actually negative 2 squared, which gives me 4 minus 36, which gives me negative 32. Doesn't matter. All I need is a negative number. Okay, so I've now determined that my discriminant is negative 32. All right, so what that means is that a squared minus 2a plus 9 is greater than 0 for all a, which means that the discriminant, this is the discriminant, is greater than 0 for all a. Therefore, x squared plus a plus 1x plus a minus 2 equals 0, has 2 solutions for all values of a. And that's it. That's the whole example. All right, thanks.